Chapter 8, Combined Loading, Application of Superposition in Combined Loading, Example number 1. This example, we study a effect of a force of 150 which is applied to the edge of a member. This is a 150 pound force concentrated load applied at one end of this structure. If we just neglect the weight of structure itself, we want to determine the state of stresses at point B and at point C. Let's see how can we approach this problem. So if you remember from statics, if we want to relocate this force, transfers this force to the centroid of the structure, it just create the opposite direction, so we can cancel out these forces with each other, and then we just have that force applied at the centroid of our section. Meanwhile, the condition of these two forces create a bending moment of a counterclockwise of moment is equal to force. Any moment is a force times r. So force is 150 and the arm is 5 inches this distance, and it just if you look at the direction of the couple, it's just a clockwise a bending moment. So one can say if we have this force replaced at the centroid, can ignore this force and have a bending of 750 pound-inches of moment in clockwise direction. So let's say the stress component, the stress due to normal force, definitely this normal force applies a normal stresses, which is a normal stress is force over the area. Force is 150, area is definitely this cross section at any point below that. So for example, any point like C and B experience a compressive stress of 3.75 pound square inches, and the other component is the bending part. So for example, if you apply a clockwise bending moment, or for example, if we call it y by the bending moment applied at this part, and it just pushes the point C and pulls up point B on the other side. So the formula for that sigma is mc over I. So if C is the farthest from point from centroid, that gives me a sigma maximum. M is moment, I is moment of inertia, and that's 750, which we have it here, times 5, which is from the centroid to point C is 5 inch in terms of length over a 112 base cube height. Height is the 10 inches, 5 plus 5, 10 cube times a 12 of 4 gives me a 11.25 pound square inches of stress. Then if we add up these two stresses together and report it like combined loading, that's all. With the help of superposition, we can add them up together and report the result like combined loading. So let's see, for example, sigma at B here and also sigma at C at here definitely consists of a compressive, a downward push stress plus a component of bending moment to each of them. Let's study each of them individually. So let's say, like for example, sigma at B stress at C is a compressive stress of M over I plus a positive MC over I. How is that? So definitely point B experiences a push of this amount of force over the whole area. But if you just remember the effect of a clockwise 17 pound each moment, it just gives us a negative 3.75 because that's a downward push, a plus because a clockwise moment about y-axis, if we call it again y, y. it just, you can easily see it is kind of a like clockwise movement. It just pushes point C and pulls point on the other side. You can easily see that's a tensile, that's a positive by, it's positive here. And the total is a positive 7.5 pound square inch. So definitely point B is at tension. That's a tensile combined effect. We just apply the same kind of story for point C. You can easily see a clockwise movement just pushes the C. So there was a compressive force of a negative 3.75 to normal force, and another addition, a tensile compressive stress due to bending moment, and it just gives us a negative 15 psi, which is a 15 psi in compression at point C. We'll solve more problems, and also if we want to see the resultant stress distribution over the cross section, it just gives us, it's equal to a, this one is equal to, so for example, if we have a condition just for normal force which we calculate, that's a 7 is 3.75 psi. If we add that with the effect of bending moment, which is 11.25 at both sides, it just gives me the effect of combined loading. So the first part is a negative, positive, a negative, then negative. So it simply gives me the effect of that the arrows are the opposite direction for these two parts. So this is a negative, this is a positive. If you subtract that, you get this much amount of push. And then that's the other part is just a push of a negative 15. That's a combined loading. And if you want to know where the location of that is, by using, if you call this distance x, and if you remember the total was 5 inches distance, so that makes it 10 inches. And then if you call this distance x, the other is 10 minus x. If this is x, the other one is 10 minus x. And if you using like a similar triangles, it just gives you 7.5 over x is 15 over 10 minus x. That's a just through the ratio of this height, and it just gives you, and if you solve that for x, it just gives you x, the location of x is a 3.30 inches. We solve more problems in combined loading. Thank you.